Model Context Protocol, or MCP for short, is a standard that was developed by Anthropic, but not exclusively for Anthropic. This is a protocol that allows us to standardize the way we communicate with LLMs. LLMs are great, but they also have some limitations. They're trained on a certain set of data. They can't get access to real-time information. So often we need to provide them context. And MCP servers are great at this. I can't believe it's not even a year old at this time, but it's really taken off and it's really been adopted by the community. Now, I've done a bunch of videos on Spring AI and MCP. If you want to learn how to build MCP servers using Java, using Spring AI, I'll leave some links in the description below. Today, I want to focus on security. Because with MCP servers, maybe we all started out like I did, building local standard in and out MCP servers that really didn't have to care about security, right? Because they're running on my local machine. But as we start to move forward, we start to realize that some of these servers will need to put in the public. And if we put these servers out in the public, we need to secure them. I had the opportunity to have the great Daniel Garnier-Moiroux, a coworker of mine, on the Spring Office Hours podcast. I'll link to that in the description below as well. And we talked about this. And so what I want to do today is go through the article that he wrote on securing MCP servers with Spring AI, look at some code samples, and talk about a couple different ways that we can secure our MCP servers. So let's do this. Let's go ahead and switch over to here and take a look at this article. And Daniel talks about it in here. We also talked about it on the podcast, that the specification for Model Context Protocol and the idea of securing MCP servers is ever changing. When it first came out a year ago, there was no anything in the spec about security. And again, this has really been rapidly evolving. So if you want to learn more about that, head over to Model Context Protocol. So there's two ways that we can secure this. We can secure MCP servers using OAuth2, building an MCP compatible Spring Authorization server, or we can use API keys. And so really it just matter of what you're trying to do, how secure that it needs to be. If you just want to quick and easy security layer, then you can use something like API keys. If you have the infrastructure in place already and you need more security, you could build on top of OAuth2 with the Spring Authorization server, or really any MCP compatible authorization server, right? So let's talk about the first one, which is securing MCP servers with OAuth2. According to the spec, MCP servers exposed over HTTP must be secured with OAuth2 access tokens. So any call to MCP server uses a header like this, where the access token is obtained from an authorization server. We can think Okta, GitHub on behalf of the user. So the MCP server must also explicitly advertise the authorization server it trusts, so the MCP clients can discover them dynamically. So the first thing you need to do is go ahead and add some dependencies. Now, one of these dependencies I want to call out is from org.springai community. If you're not familiar with the Spring AI community, this is a really great place for community projects. It's also a really good place for projects that the Spring team is working on, where they can kind of incubate, right? This is just kind of a place to put them, test them out before they move under a official repo. But this is also places where community members can go ahead and submit projects, not only just code projects, but one of the documentation projects that I worked on was Awesome Spring AI, which has a list of resources for Spring AI. But if you go in here and go to repositories, you will see the MCP, where did I miss it? MCP security, because I clicked on it yesterday. And this will talk through some of the, really what this is as Daniel described it, is the glue code between Spring Security and securing MCP servers. So that is a really good place to start. Now, this is the code that we're going to go through today, at least one of them, which is the OAuth2 resource server with the authorization server. There are a lot of moving parts here. And again, maybe you don't have the infrastructure for this, but maybe you do. And if you're going to go ahead and secure an MCP server this way, at least for me, I had to get a mental model of like how this works. So in this project, I have the authorization server and the MCP server both in the same project. Just easy to kind of share with you guys. But in the real world, you probably have those as separate projects. But this walkthrough says, okay, we're gonna go ahead and authorize the request. We send it through an authorization server. In this case, I'm using an IDP or an identity provider. In this case, I'm using GitHub as the OAuth provider. There are a bunch of OAuth providers out there. You can use the major ones like Google, Microsoft, Apple, Twitter, GitHub, etc. There are also enterprise IDPs. So Okta, OAuth, Auth2, Keycloak, Active Directory, AWS Cognito, etc. So in this case, the authorization server is handing the authorization aspect off to GitHub OAuth. And then we have the authorization server, which actually issues the JWT with the GitHub identity. We return that to the client. Now the client calls with that JWT to the MCP server and then returns that. The reason that we do this, so again, we're talking about Auth server and GitHub. We're federating authentication with GitHub OAuth. Auth server delegates or outsources the actual user authentication to GitHub rather than handling that directly. There's some more examples in there. What your authorization server does do versus doesn't do. So what it does not do, it does not store user passwords, manage user accounts, handle password resets. What it does do is redirect to GitHub, in this case, receives the GitHub's yes, this is user X response, creates its own JWT token based on the GitHub's confirmation, etc. And in this case, I just added something, Y Federation. Think of it like a nightclub bouncer, right? The bouncer is your auth server. It doesn't know everyone personally. Instead, they check, in this case, government issued IDs or GitHub authentication. They only trust the DMV. GitHub already verified the person's identity. We're not going to go through and do like a background check on everybody as a bouncer, right? This has already been done for us. Once verified, they give you a wristband, which is the JWT, and you are allowed access into the club. So I put this together to kind of walk through that. We'll walk through the code, but I thought that was interesting. So we'll take a look at the project in a second, but we start with those dependencies. We want to define the server. So in this case, we're creating an MCP server. Again, I've gone over this in different videos in the past. But in this case, you can say, hey, this is streamable. In my case, I'm going to use stateless. Again, something we talked about yesterday is the difference between stateless and streamable. If you're not doing any of the advanced things like logging and solicitation and a couple other things, I can't remember all of them, then you can just use stateless if you don't need to like keep that connection open. So I'm going to use stateless, and then you define an authorization server. In this case, we have started our own authorization server using the Spring authorization server that's going to run on port 9090. So I'm going to switch over to my IDE. And this is that project that we have here. So we have an authorization server. We have an MCP server. The MCP server just exposes a couple tools, one which is echo. So it'll take in whatever message you have and give it a timestamp and echo that out. The other one is going to get some information about the currently authenticated user. And so the way that this works with Spring Security is you use the security context holder to get the context and then get the authentication. From there, we have that information about that user. We can go ahead and print it out. So then we also have the idea of setting up the security for this MCP server. So the way that we do that now is we define a bean of security filter chain. We're going to put this in a class, a configuration class, enable web security. And what we're going to do in here is we're going to basically lock everything down. So any request that comes in, we want to be authenticated. If we are going to be dealing with cores, in this case we are, because we're going to test this from the MCP inspector tool. So you'll want to go ahead and enable cores. And then we aren't using CSRF, so go ahead and disable that. Here's where the new stuff kind of comes in. And the with method is not new. I kind of cleared that up with Daniel. But the with method takes in a configurer. So it takes in a configurer and a customizer. And so this is coming from that Spring AI community project, that kind of glue that puts this together. So here is the configurer. So we see that here. And then this is the customizer. And what we're doing with this is we're saying, here is the authorization server. So we're defining this as a URL. This is just localhost 9000. And then this is optional, as Daniel says. We can kind of validate that the audience claim is in the JWT token. This I've kind of covered before. This is just course configuration. We're just saying, hey, for this, we're allowing everything. Again, if you were doing this in production, you may want to tighten this down a bit. But that's all it is from a security standpoint, from the MCP server standpoint, right? So now we've defined this authorization server that it's going to reach out to. So when this kicks in, it'll say, okay, I need to authorize with an authorization server. So the authorization server here, we have not a lot going on. So just this. We have this security config. So in the security config, we're doing something very similar. We are saying, hey, any request that comes in, we are going to authorize it, or it needs to be authenticated. We are disabling, or we're setting our cores here. And then we're saying OAuth2 login. We want to be able to log in with OAuth2. So somewhere in the configuration settings, we're going to have to define what OAuth2 providers we're going to support. In this case, it's going to be GitHub. And then here's the new bits. So this is coming from the Spring AI community project. It says with MCP authorization server and with defaults. And again, here's that with method, which takes in a configurer and a customizer. So the configurer is this, which is coming from the Spring AI community projects. The with defaults is really just like an empty Lambda expression. So this is what we have for our configuration. Now, when you set up an authorization server, there's a little bit of boilerplate I got to set up here. This is the OAuth2 resource stuff. So at this time, I'm saying, hey, I am going to configure GitHub as federated login, which means as an authorization server, I'm not checking credentials. I'm going to hand that off to GitHub. So I have some examples here of how to go off and create an OAuth app or create a callback, which is also in the README for this repo. But you're setting up a client ID and a client secret, and now we're handing off authentication over to, or authorization off to GitHub. For an authorization configuration, this is kind of just plain stuff that I've pulled, right? From getting started with authorization server, like Spring Auth server. So we have a client ID. Well, we're registering different clients, right? In this case, I'm registering just that MCP server. That's the only kind of client talking to this auth server. And we're defining some credentials about that, like redirects, scopes, etc. So you can just kind of copy that if you want. We're setting this to port 9000, and we're setting some logging. Okay, so those are all the kind of pieces and parts to the OAuth2 flow with the authorization server, right? Let's see this in action. So what I want to do is I need to start the authorization server first. If I am in something like IntelliJ, I have this services pane, which if I have a multi-module project like I do here in Maven, I have multiple services that I need to start. I want to make sure the auth server starts first, and it does. And then I want to go ahead and start the MCP server, which it does. Now, once both of these servers start, I've got to figure out how to do this handshake. And Daniel talks about this in the article. You can go through and try to do this from the command line. It's a little bit mind-numbing, like to try to figure this this dance out, right? So I normally test my MCP servers in something like the MCP inspector anyway. So I'm going to go ahead and run that. So here we are in the MCP inspector tool. And what I want to do is I want to connect to an MCP server. In this case, we're using streamable. I know it's stateless, but we're using streamable HTTP. The endpoint for that is localhost 8080/MCP. And then we want to configure authentication. So if we go in here and open authentication, here is that OAuth flow process. It has to do metadata discovery, client registration, prepare authorization, request authorization, and acquire that code, get a token, authentication is complete. So there's a lot that goes on here. Luckily, the MCP inspector tool makes this pretty easy. You could do a quick OAuth flow, which if it works, it will just go through and authenticate for you. If you are having problems, you can do a guided authentication flow. So maybe these first two work, but then it doesn't work at preparing authorization. Now you have some insight as to what is going on and where. So I'm going to go ahead and try and do this. Let's see. It goes through authentication complete. You can see the access token. We are good to go. This means that we can go ahead and connect to this. But the is not working. So I think this is an issue with what is going on here. Oh boy, we have a lot going on. So let's, okay, so I found the problem and that's okay. That's why it was running. Now we can go ahead and try this again. Again, I'm going to go into OpenAuth flow, try a quick OAuth flow. Looks like it's going, and now I can connect. So believe me when I say this, if you want to test the OAuth flow, probably doing it from the command line in a browser is not the most fun thing. Being able to test it right here inside of the MCP inspector, really nice to do. So if everything works, you'll be able to connect to your MCP server. And you can go in and say list tools. So we have that one, which just echoes back a message. So hello world. And if we run this tool, it'll echo that out with a timestamp. Here's the interesting bits. Now we can get the current user. So we're going to run the tool and we see we get the authenticated user. This is because I'm already logged in with GitHub. When I did that flow of do the OAuth flow, if you weren't logged in already, you would have to, it would open up a browser, you'd have to authenticate, and then things would work. But I've already done that, so it worked for me right off the bat. But that is my GitHub user. We have federated. We've handed that off to GitHub to go ahead and authenticate for us, which is nice. So that worked out really good. So there's an example in the in this repo here. If you want to follow that and kind of build a mental model and you want to download the code and run, the only things that you'll need to do is kind of set up a GitHub client ID and a GitHub secret. And if you export those, or if you just want to hard code them in the project for a minute, that's fine too, but don't do that for long. We don't want to submit those secret keys. And then there's some examples in here on like how to get started. So that's step number one, the kind of OAuth2 flow, right? I want to quickly show you the other one. So let's stop all, and then I'll go over to this one. So again, we have these simple MCP tools. We have one called Echo. We have one called Get Current User. Now we're going to look at this MCP security config. Again, we're just using Spring Security. We're defining a security filter chain. We're using this with method after we've kind of said everything is going to be authenticated. Now we're saying with MCP API key configure. So here's a new configure, and then the customizer, here's how we're going to customize it. So the API key entity in this case is this, and it just has a get authorities and a copy method. So we have an implementation of that here, and this is something that you can go ahead and create an implementation of it as well. But all we're doing here is setting an API key. And at this level, all we're doing is setting it in memory. So we are returning a new in-memory API key entity repository. You can certainly do this however you see fit. In this case, it just makes sense to have just a simple list of API keys, in this case, one. So I have an API key of dvega, and my secret is my custom API key. So anybody who accesses this MCP server needs to be authenticated. And this is how we are going to authenticate. So let's go ahead and try and run this application. And if we were to just try to make a request to something like 8080 MCP, you'll see that we get a 403. We are denied. We are not allowed to use this, right? So again, we can come back over. I think, is this still running? Let's just kill this. And we'll come over here and we'll say that we're going to run our MCP inspector tool. So now, once this launches, instead of going through the OAuth flow, which we did before, now we can come in here and say that we are going to use a authentication by a custom header. And if you look at Daniel's article, it's because we're going to use the X API key and then a certain value. In this case, the value is going to be dvega.myCustomAPI key. So if we go ahead and do that, we can connect, we can get our tools. Here's our list of tools. Who is the current user? In this case, it's dvega. Now I will point out that Daniel has an example in here. And he said, so we just kind of went through that. We went through that same thing. And he talks about it here. Now the important part here is the secret is stored in bcrypt hashed form on the server side. So the MCP Server API key configure offers options for changing the header name, even dedicated APIs to extract the API key from the incoming request. Because it's using bcrypt, again, if we have something that has like very high throughput, we want to be careful with this because that is going to take a lot of processing, right? All right, I think that's a good place to stop. I thought Daniel did a really good job of laying the different ways that you can secure your MCP servers in this article. So I'll make sure to share that below. If you are running MCP servers on your local machine, this is something you don't have to worry about. But as we start putting these MCP servers in the public, this is absolutely something we need to worry about. And we have a couple different ways that we can secure them here. So thanks, Daniel, for the wonderful article, the wonderful conversation we had on Spring Office Hours. Appreciate everything you do. And if you have any questions about this, please do me a favor, leave them below. And let me know if you are putting any MCP servers out there in public. I have one. I built one. I talked about this in another video that I did. But if you go over to danvega.dev and you go down to MCP, you can learn about just a silly MCP server that I put together called Dan Vega as a service. And just an example of something built in Spring AI that I put into public. I have not secured this yet. I may secure this via some API keys if I need to like lock it down and restrict it, but I haven't done that yet. So I thought that was a lot of fun. Very important to understand. The more MCP servers I see going out into the wild, the more articles I see about some vulnerability being made or compromised. So this is something that we all need to think about. I had a lot of fun putting this together. If you learned something new today, friends, do me a big favor. Leave me a thumbs up, subscribe to the channel, and as always, happy coding.